Hello, good morning. Today I would like to discuss about numpy. How to use numpy in Python. See, numpy it is a library for Python programming language adding support for large multidimensional arrays and matrices along with a large collection of high-level mathematical functions to operate on these arrays. It is a library which is working with array, and it also has functions for working in domain of linear algebra, Fourier transform and matrices. You can go with W3 schools. Numpy tutorial is always here and different examples are given here. See, first of all we have to import numpy. How to import numpy? Import numpy as np. Then check Python and numpy version. Import platform, print Python version, concatenate plus platform.python version, Python version and numpy version. Numpy data types. A list of numpy data types. Here we have to create a data frame with data types and type code. Import pandas as pd. D types data types is equal to pd dot data frame. D types is the name of data frame. Pd dot data frame, it will create data frame with this data type and type code. Type, int, different data types are there, and type code. See, create an array with a specified data type. F4 is the code, float 32 means F4 print array np dot array 1 2 3, these are the elements of array, and d type is equal to F4. Then print array dot d type. It displays array element and data type. Like that, here d type is equal to np dot complex 64 means this data type. It will display array and array type. Like that, d type np dot boolean, then it will display 0 1 1, false true true. Print array, it displays the value np dot bool, d type np dot bool, then it will display false true true because 1 1 and 0, and data type is a bool. Like that, we have to create an array with different data types. String data type. Set the max length of the string using s plus some number. String and number. Length of a string is 3 and then data type is s. String data type. It will display print s dot data type, it is a s3, and it will display strings. If we have to set the max length of the string is 3, therefore it truncate G from this value. Therefore, it displays DEF here. Then NumPy string and Unicode data types. np.array dtype np.string. It will display array data type S3. String data type is there, and np.unicode, it displays Unicode data type U. Create an array from a Python array. Array is equal to np.array range 10. It will create array 0 to 9. 10 elements are there in this array. np.array 1 2 3 4 5. Print array. It will display value of that array. Create an array in a specified data type. I2. C. Integer data type. D type is equal to I2. Print array 1 2 3 4 5 6. Array of evenly spaced values within a specified interval. C. np.arrange start, stop and step. Start with 0, stop with 20 and step is 2. Start with 0, step is 2, 4, 6, 8, 10 and stop anywhere the value becomes 20. Create an array of evenly spaced numbers in a specified interval. Create an array of evenly spaced numbers in a specified interval. See, line space, start, stop, number of elements, end point and step. See, start with 0, stop with 10 and number of elements are 20. It will display this array. Like that you can create different types of arrays and data types. Array of random values in a given shape. Random.random 33. It will create a random number array. Array of zeros in a given shape. Array of zeros. 2 rows and 3 columns. Create an array of zeros with the same shape and data type as a given array. np zeros underscore like array print zeros. Create an array of ones in a given shape. Ones is equal to np.ones, 2 rows and 3 columns. Print ones. Create an array of ones with the same shape and data type. Ones. Create an array of arbitrary values in a given shape. 2 rows and 3 columns. Print empty. Create an array of arbitrary values with the same shape and data type as a given array. Create an array of constant values in a given shape. We have to give constant value for the array. Array of constant values with the same shape and data type as a given array. Create an array by repetition. np.repeat array. Array is equal to 0 1 2. np.repeat array 3. Range 3. It will repeat one element with 3 times 0 0 0, 1 1 1 and 2 2 2. Range 3. Array and repeat 3 times. Okay. np.repeat iterable repetitions and x is equal to none. Repetitions 3. Repeat along a specified axis with specified number of repetitions. 1, 2, 3, 4. Print np.repeat array 1 to axis is equal to 0. Specified number of repetitions. 1, 2, 3, 4. Repeat along a specified axis with a specified number of repetitions. Array is equal to 1, 2, 3, 4. Print np.repeat array, comma 1, 2, comma axis is equal to 0. It repeats second element. First row, second column. It repeats by this element. Repeat an array by a specified number of times. Array is equal to 0, 1, 2. Print np.tile specified number of times array, comma 3. It will repeat 3 times. Repeat along specified axis. Array 2, 2. Repeat along specified axis. Create an identity matrix with a given diagonal size. Identity matrix is equal to np.i3. Print identity matrix. Diagonal elements are 1, that is called identity matrix. Create an identity matrix with a diagonal offset. Different positive number shifts the diagonal upward. Extract the diagonal array, create a diagonal array. Here 5, 5. 1, 2, 3, 4, 5. Elements are the random elements. Are there? Extract the diagonal np.diagram diagonal array. Only diagonal elements it displays here. Suppose we can take any. First we have to create the identity matrix and then display diagonal elements using np-random np.diagonal and array name. Create a matrix with a specified diagonal array. Suppose you want to specify there is diagonal elements 1, 2, 3, 4, 5. Then you can display this with np-diagonal 1, 2, 3, 4, 5. It takes the diagonal elements like 1, 2, 3, 4, 5. Inspect arrays. np.array 1, 2, 3, 4, 5, 6. Retype np.int64. You can inspect arrays like that. See, inspect arrays. Inspect arrays. General information of array. Inspect the general information of array, info of array. Inspect the data type of an array.dtype. Inspect the dimension of an array.shape. These are the important features of a numpy array, which is used in machine learning, in data science. Array.dtype. Inspect the dimension of an array. Print arr.shape. 2 columns, 2 rows and 3 columns. It will give the size, shape of the array. Inspect length of an array. Length of array. Inspect the number of dimensions of an array. Inspect the number of elements in an array. Array dot size. Inspect the number of bytes of each element in an array. Atom size. Bytes of each element in an array. Inspect the memory size of an array. Array dot n bytes. Sampling methods. np dot random dot seed 123. Set random state which is independent from the global seed. Random state 21. Random 10 from this. Generate a random sample from interval 0-1 in a given shape. Generate a random scalar. Generate a one-dimensional array. One-dimensional means only single row is there. One-dimensional array. Generate two-dimensional array, rows and columns. np.random.arraynd. Here np.random.arraynd rows and columns. You can generate two-dimensional array. Here generate a sample from the standard normal distribution. Means mean is equal to 0 and variance is equal to 1. Then it will generate random distribution, standard normal distribution with mean 0 and variance 1. Array of random integers in a given interval low and high. Low high size d type. np.random integers. Low 1, high 10, size 3 and d type i8. Then it will display 572. Generate an array of random integers in a given interval. Size is 3. It displays 572. Random numbers. Generate an array of random floating point numbers in the interval 0.0 and 1.0. It displays floating point numbers in the interval. np.random, random sample 10, random ranf 10 and sample. It will display. Output is same for all this. It displays random, therefore it differs in number. Generate a random sample from a given one-dimensional array. If you want to random sample from the array, then here random dot choice, iterable, size, replace and weights. Different commands are there. As per our requirement, we can use these commands in data science. When you analyze the data, you can use different commands. Generate a permutation of an array. A permutation of the array. You can take permutation of array also. Then math function np.random.arraynd 55. Element wise addition, subtraction, multiplication and division. Array plus 10, array minus 10, array star 10, array divided by 10. You can take element wise all the mathematical functions, addition, subtraction, multiplication and division. Array 1 is equal to np dot array 1 to 3. NumPy built-in functions are there for addition, subtraction, multiply. You can use np dot add array 1 you can take array 1 890 out array 1. NumPy built-in functions are there for addition of array. It will display addition, subtraction and multiplication. np dot array 1 to 3. Here array 1 890 out array 1. See, array 1 is equal to 1 to 3 and here addition 890, therefore 8 plus 1 9, 9 plus 2 11 and 13 plus 10 plus 3 13. It will display additions. Like that, subtraction 8 minus 1, subtraction and multiplication. Like that, it will display mathematical inbuilt mathematical functions. See this output. Suppose print array 1 and print subtraction 9, 11, 30 and subtraction. It will display 1 to 3. Element wise exponentiation, element wise logarithm. You can take log of array base 2 log 2 array log 10 base 10 array, element wise square root of array, sine cos, element wise sine cos. You can take along a specified sum along a specified axis. np dot sum array axis is equal to 0. ARR, it takes value of array and then display summation of array. Sum along the column, axis is equal to 0 means sum along the row, and sum along the column means axis is equal to 1. Compute the mean and max along the specified axis. np dot mean, max along the column, max mean in all the elements. Compute the index of the mean max along the specified axis. Along the column, x is equal to 1, x is equal to 0. If x is not specified, return the index of the flattened array. Compute element wise mean and max of two arrays. Maximum of array 1 and array 2. One, 4, 5, 8, 9 means it compares elements of first array and second array. Then here minimum 0, 3, 3, 7, 7. Split fractional and integral parts of a floating point array. It can split fractional and integral part of floating point array. Suppose array of floating point numbers are there, then it will split the fractional part and integral part. Fractional and integral, you can store RE and INTG. Compute the mean. np.mean of array. np.mean array x is equal to 0. Compute the mean along the row and compute the mean along the column. Compute the median. np.median of array. Compute the median along the row. Compute the median along the column. Compute the percentile. In any percentage up to 25%, 70%, 50%, 75%, 100%, you can calculate percentiles of the array. Suppose we want to calculate percentile 5, 65, 95, then give us np dot percentile array 1 and then give the numbers, percentile numbers. Compute the standard deviation and variance. Overall standard deviation STD of array. Compute the standard deviation along the row, along the column. Overall variance VAR, np dot VAR, variance in between the values. Compute the variance along the row, along the column. Covariance and correlation, np dot covariance and np dot correlation coefficient. These all are statistical terms which are used in data analysis and machine learning to see the relation between elements. You can read using Google what is covariance, correlation, mean, median, mode. See the various examples are given here. In this explanation I want to give only introduction of commands with these terms. Variance, standard deviation, then compute the covariance, correlation. COV is the correlation, covariance, and correlation coefficient. 0 means according to row and 1 means according to column. Cumulative sum and product. Cumulative sum of array. Along the row means x is equal to 0, along the column means x is equal to 1. Calculate the cumulative product along the row. Cumulative product. Cumulative product along the column. Element wise comparison. Array 1, 1, 2, 3, 4, 5. Array 2, np dot array 5, 4, 3, 2, 1. Return an array of bools. Means you have to compare the array elements. Array 1 is equal to array 2. Print. If elements are equal, then it will give true. Otherwise, it give false. Only one element is equal, common in both arrays, 3, 3. Therefore, it gives true here, and other elements are values is false. And then 5, 4, 3, 2, 1. If array 1 is less than 3, it will check. If element is greater than 3, then it will give false. Slicing and indexing. Array is equal to np.array range 100 dot reshape 1010. Select an element by row and column indices. These are the terms which are very useful in data analysis. Indexing with slicing, we can split the array. We will see later details of this. Indexing with slicing. Sort an array np.sort as according to row, along the row, along the column. Sort the column, sort the row, and then compute the indices that would sort an array along a specified axis. It will give indices. Indices means arg sort with column and with row. Manipulate an array transpose of an array. What is the transpose? You can see if you have knowledge of mathematics, you can clear these concepts. Mathematics and statistics is required here. The following methods return a copy. Array dot t means it gives the transpose. np dot transpose, array dot transpose. How to change the shape of an array? Return the copy 2 by 6. Reshape of array. It can create a 2 rows and 6 columns. Resize. You can resize the shape of an array. Append elements to an array. To np dot append array, initial array and append value. It can append the value and it store into new variable, and you can print that variable array. Append an array and return a copy. 4 5 6 1 2 3 4 1 2 3, and then it appends 4 5 6 and return its copy, means print array 2. Insert elements into an array. np.insert array. Insert a scalar at a certain position 0, 100. 0th position you can insert 100. Therefore it will insert 100 1 2 3. Using position you can insert multiple values, you can insert at this position. Delete elements np.delete means 0 position value, you can delete that element. Remove the element at multiple positions 0 and 2. It deletes multiple values. Copy an array. np.array 1 2 3. np.copy array 1 array.copy or np.array. You can see the output here. copy an array, here you can insert print array 1. Print array 1. np.copy or array.copy or np.array, initial array and copy is equal to true. 246 copy an array. Combine and split an array. Combine means concatenate, np.concatenate array 1 array 2. Axis is equal to 0 means row wise, and here it will display axis common wise. Axis is equal to 1 column wise. Stacks arrays vertically and horizontally means H stack and V stack. Split an array, split the array vertically and horizontally. Set operations, np.unique elements from an array, np.array, return the number of times each unique atom appears, means 1 will appear by 2 times to appear with print uniques and print counts. Compute the intersection and union of two arrays. Intersection means its common values between array 1 and array 2, and union, it combines two arrays. Compute whether each element of an array is contained in another. Array 1 and array 2. If contains array 1 element contained into array 2, then it gives array 1, array 2, 1, 2, 3, 4, 5. 1 is available in array 2, therefore not available, therefore it gives false. 2 is not available, therefore it gives false. 3 is not available, 3 is available, therefore it will give true. 4 is available, the value is true. And 5 is available, therefore it gives true. Like that, we can compare two arrays. Compute the elements in an array that are not in another. You can set difference between two arrays. You can take difference between two arrays. Set difference means 1 and 2. Other elements are common. Compute the elements in an array that are not in another array. Compute the elements either of two arrays but not both. Means 1, 2 and 6, 7. Linear algebra, random values, matrix multiplication, print array 1 dot dot array 2, dot array 1 array 2 or array 1 dot array 2 or np dot array 1 array 2 or array 1 at array 2. Meaning is same for matrix multiplication. inverse of a matrix, linear algebra dot inb, and give array. It will display inverse of a matrix. Like that, you can use various mathematical and statistical function with in numpy, and it is very useful with data analysis, data analytics. When you reprocess the data, then it is used for the analysis. This is a rapid survey for you to how to use all these commands with the data frame, array. I hope you understood all the concepts. Do practice of all these commands with Colab, Google Colab or Anaconda. Anaconda desktop version is available. I already explained that how to install this Anaconda version, or otherwise you can use Colab. Thank you.